Hey, Dr. Garmire, it's Jordan.
Manoa.
We're working on the RF detector project using graphene technology. I'm doing it for my 496, and Noah's doing it for his 296. So, like, over the past week, or a few weeks, we've been working under PhD student Richard Ordonez, assisting him to design, fabricate, and test a quantum RF detector that he's been modifying over the course of his research here. So far, we've been testing the board with and without graphene, analyzing the voltage offset through MATLAB, and trying to draw a conclusion from the given results. What we hope to find through the research of the project is how the graphene is reacting with the circuit, and see if using graphene for RF detection can be used in future technology. So now I'm going to go over the physics of the graphene and the properties of the circuit. So graphene is pretty special because it has zero band gap. So what that means is that there's going to be a valence band around the nucleus and also conducting band. And the gap between is the amount of energy needed to get between the two of them. With graphene, there is no band gap, so the electrons are free to move around. So to apply it to our chip, we placed it on top of 4 rails. So we have the V plus. We have we have a voltage source at the bottom, which is creating electromagnetic fields. So the E fields are pushing the electrons to one side and creating a potential on both sides of the graphene. So then we take a differential amplifier, which is connected to the in plus and the in minus terminals. Here's our differential amplifier. This will send out an output depending on what the voltage drop is across the graphene, so we can get a reference point when we're not using hitting the board with the RF signal, and if our hopes are if we do hit use an RF, we can figure out what kind of RF that is after measuring the input or output. So Noah's going to talk about the fabrication process right now.
So the fabrication we did for this project was all done on the 4th floor of Holmes Hall in the fabrication laboratory. The first thing we needed to do before we even fabricated was to design the circuit board, which we did in the CAD program Eagle. This program allowed us to convert the files into Gerber files, which are files basically that the CNC machine will recognize, that will allow us to drill and isolate the circuit, and from there we can actually drill out the circuit board. And once the circuit board is done, this drilled out, we can electroplate it because we needed to have a top and bottom layer for the circuit board.
Yeah, so Richard and I perfected our electroplating process last semester for my 396. So what we do is put it into an electromagnetic or electroplating machine. We fill up a container with a copper acid, hang the circuit board with 2 electrodes, which are connected to the machine, put a voltage through the copper solution, so that the copper gets really excited and attaches itself to the conductive ink we have on the board.
And yeah, basically after we've done the electroplating process, we then put a solder mask on it, which will prevent oxidation, or at least reduce oxidation that can happen to the copper on the board. And since then, we've been just testing the circuit board with Richard.
I'm working on creating an RF shield for our board. Seems like there are a few different types of materials that we could use, so we're not getting interference from the rest of the board. We just want the RF signals coming from our antennas. So I'm going to try to manufacture that within the next month or 2 weeks. Should be okay. I think that's it for now. Thanks, Dr. Garmire.
Thanks.